Hello friends, in this video we are going to be looking at how we can utilize Simpson's a third rule and 3 out of 8 rules. So we are going to be using this example, integral of 1 out of 1 plus x squared from 0 to 6, and we are using 7 ordinates. So what do we mean? Right away, let's look at the solution for this problem. So if they tell you that you are going to use 7 ordinates, it means there are 7 x values. So if you start from x0, then you'll end at x6. So that means if you have n ordinates, the subintervals are going to be n minus 1. And this is going to be 7 minus 1, which gives you 6 subintervals. So if there are 6 subintervals, and I need to look for h. So h, which is equal to b minus a out of n. This is a is equal to 0, b is equal to 6. So this will be 6 minus 0 divided by 6. And this is going to be 1. So that means from one x value to the other, I'm going to be jumping, or I'm going to be having a step of size 1. So if I start from 0, I'll go to 1, I'll go to 2, 3, 4, 5 to 6. And that is the end. So how many ordinates? 1, 2, 3, 4, 5, 6, 7. So I'll go back 7 ordinates, but with how many 6 subintervals? 1, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So I'll be having 6 subintervals, but I'll be having 7 ordinates. So I go ahead and start substituting in my values. So if I substitute in here, this means, so f of 0 is going to be 1 out of 1 plus 0, and that is going to be 1. Okay, so I substitute in other values. For x is equal to 1, so I'll have 0.5. So let me make this 1.0, then 0.5. Maybe let me use 2 decimal places. So if I put in 2, that should give me 0.20. If I put in 3, that should give me, it should give me 0.10. If I put in 4, that should give me 0.059. Okay. If I put in 5, this is giving me 0.0385. If I put in 6, it is giving me 0.027. So you can increase the level of accuracy, maybe making them 4. Okay, so from there, so I'm just trying to be uniform. I'm emphasizing uniformity here and the consistency in as far as the degree of accuracy is concerned. So what else? I'm going to use the 3 rules of Simpson. So here I have y0, I have y1, y2, y3, y4, y5, and y6. So you can see this is odd. I mean, this is even, this is even. This is odd, and that is odd. So if I'm to use a third rule, okay, let me begin with Simpson's a third rule. So it means integral from a to b of f of x with respect to x approximates what? Approximates to h out of 3 into y0 plus yn. Okay, I add there 4 into y1 plus y3 plus, obviously, if I'm to use now this, this is going to be y1, y3 plus y5. Okay, Then I'll add 2, okay, 2 into what else? It's going to be y2 and y4. So y2 and y4. So this is going to be y6. And that's all. So what I do, I am going to substitute in my values. So if I substitute in my values, I'm going to be having integral from 0 to 6, 1 out of 1 plus x squared with respect to x will approximate to what? So let me put my h. My h is already 1 out of 3 into, so y naught, we said it is 1.00, okay, plus, what is y6? It is 0.027, 0, okay. Then we add 4 into, so this is 4 into 0.5, okay, 0, because that's what we have here, okay. We add y3, which is 0.100 plus y5, which is 0.0385. Then we add 2 into y2 is 0.2 and y4 is 0.059. So this approximates to 1.35708. So if I choose 3 decimal places, then I'll have 1.357. This is 3 decimal places. So you use your calculator and do this integral, you'll see that the value is within that. So let's proceed and now utilize the 3 out of 8 rule, Simpson's 3 out of 8 rule. So Simpson 3 out of 8 rule suggests that the integral, okay, from a to b of f of x with respect to x approximates, okay, to 3 h out of 8 into y naught plus yn plus, we said 3 into y1 plus y2 plus y4 plus y5, okay, up to yn minus 1. Then we add twice of y3 plus y6 up to yn minus 3. This is the formula that we use. And now, if we are now integrating from 0 to 6 for 1 plus x squared with respect to x, this will approximate 3 out of 8. And what is our h? Our h is 1. So into y naught, our y naught is 0 point. Okay, we have 1. We have 1. Then plus 1 plus yn, which is y6, and our y6 is given as 0.027. Then we are going to add 3 into y1. So y1 is 0.5, y2 is 0.2, y4 is 0.059, and that's all. Yes. Then plus 2 into y3, because y3 is what we only have, and y3 is 0.1. So let's do the computation and see. So this gives me 1.35708. So this approximates 1.357, 3 decimal places. So this one is equal to, I've recalculated, and this is equal to 1.366. So 1.366 to 3 decimal places. So when you compare the two, you'll find that they are close to the answer. And if I calculate from 0 to 6 integral of 1 out of 1 plus x squared with respect to x, so I'm going to use my calculator, and this is going to be, so integral of 1 divided by 1 plus x squared, okay, from 0 to 6, okay, from 0 to 6. What is that going to be? So my answer is 1.4056. So this is 1.406 from the calculator. So if I compare with the above rules, I'll see that the error for 1 out of 3 rule, this is going to be 1.406 minus 1.366. So 1.406 minus 1.366. So the error here is 0.04, and the error for 3 out of 8 is 1.406 minus 1.357. So 1.406 minus 1.357. So here I'm getting approximately 0.05. So you can see that the third rule approximates the integral better than the 3 out of 8 rule. And this is because the function that we are integrating has x squared, which is the polynomial that we use while deriving the 1 out of 3 rule, or the third Simpson's rule. So that's why you see this third Simpson's rule is estimating this or evaluating this integral better than this.